Let's go. As 2 x 2 in 3 2 methyl pent 1 in. What other isomers we have? 3 2 methyl pent 2 in. X3 in. Yes. 3 methyl pent 2 in. 2 3 di methyl boots 2 in. Yes. 3 dimethyl boots 1 in. What's the ninth one? 4 methyl pent 1 in. We can see that all these ones are isomers of benzene. And you see that all these ones, all these compounds, they have the same molecular formula, which is 6,6H12. But their structural formula is different. So they are isomers. We have a solute event in a solvent. What do we have? Solution. We have a solution. You know, as you are adding salt to the solvent, the salt will dissolve. It will get to a time that the salt will no longer dissolve. They will say the solution is saturated. Now, the maximum amount of the solute that dissolves in 1 dmq of a solvent is referred to as solubility at a particular temperature. So you can say solubility of a solute at a given temperature is the maximum amount of the solute that dissolves in 1 dmq of solvent at that particular temperature. Now, if we want to calculate the solubility of a salt, we can use this formula to determine the solubility of a salt. Remember, solubility can be measured in mole per dm cube. We can have it in mole per dm cube, or we can have it in gram per dm cube. Now, solubility is equal to the mass of solute over molar mass times 1000 divided by the volume of solvent. This is solubility in mole per dm cube. So solubility in mole per dm cube of a solute is equal to mass of the solute over the molar mass times 1000 divided by the volume. Most time, it depends on what you are asked to calculate. You may be asked to calculate the solubility of a solute in solution, or you may be asked to find the solubility of the solute in a solvent. If you are finding the solubility of the solution, you are going to use the volume of solution here. And if you are having the solubility of the salt in a solvent, so you are going to make use of volume of the solvent. So you have to look at the question given to you. If the reference to that solubility is the solution, you use volume of the solution. And if it's reference volume of, solubility of the solute in a solvent, so you are going to use volume of solvent. Now you can as well calculate the solubility of the salt in gram per dm cube. So solubility in gram per dm cube is equal to mass of solute over volume of solvent times 1000. Please take note of the formula and take note of the unit you want to calculate. Solubility in mole per dm cube is equal to the mass of solute over the molar mass times 1000 divided by the volume of the solvent. And of course, the solubility in gram per dm is equal to the mass of solute over volume of solvent times 1000. So let us look at an example here. The solubility in mole per dm cube of copper 2 tetraoxosulfate dissolved in 100 grams of water. Dissolved in 100 grams of water at 120 degrees centigrade. You can write in bracket C is equal to 64. S is equal to 32. Then O is equal to 16. Now, the question says we should find the solubility of the salt in mole per dm cube. That means what's appropriate for that calculation is this. But from the question, mass of water is given, which is the solvent. And from this formula, we are using the volume of the solvent. What we need to do is to convert that mass to volume. How do we change it? Density of water is equal to 1 gram per centimeter cube. Then we can convert the 100 grams of water to volume. So we use as the density of water is equal to 1 gram per centimeter cube. And we know density is equal to mass over volume. So 1 is equal to 100 over V. Then V is equal to 400 over 1, which is 100 centimeter cube. That means the volume of the solvent here is 100 centimeter cube. Then we can use the formula solubility is equal to, we say solubility is equal to mass of solute. Mass of solute over the molar mass times 1000 divided by the volume of solvent. What's the mass of solute given? 40 grams. 40 grams. We have to calculate the molar mass of the salt. The salt is CuSO4. That means we are going to add the 10 masses of this is 64 plus 32 plus 4 atoms of oxygen will give us 64. Then times 1000 divided by the volume of the solvent is 100. This is 40 over 160. What do you have here? This is 40 over 16. And we can reduce this one. 8 will go here 5, 2. That is what? 2.5. That is 1.1 mole per. So the solubility of that salt is 2.5 mole per km. So you say solubility is always solubility in mole per kg is always 0 point. No. There is no rule that says the solubility of a salt must be 0 point. No. Is that taken? So there is no constant or standard solubility for any salt. It is not necessary that the solubility must be 0. There is no rule that says that. Whatever you get when you do the calculation is what you are going to write. When you find the solubility to be 100 points or 200, it depends on temperature at which the solubility occurs. Solubility of a solute is directly proportional to its temperature. The higher the temperature, the more the solubility of a solid. Is that taken? So let us have another example. Another example. Gram of magnesium chloride. Gram of magnesium chloride was placed in 50 centimeter cube of water. 90 gram of magnesium chloride was placed in 50 centimeter cube of water to give a saturated solution. At 298 Kelvin. If the solubility of the salt is yes, 90 gram of magnesium chloride was placed in 50 centimeter cube of water to give a saturated solution at 298 Kelvin. If the solubility of the salt is 8.0 mole per Gen cube at the same temperature, what is the salt left on the salt? When we started the class, I said when you dissolve salts in water, it will get to a time that as you are adding the salt to water, the salt will no longer dissolve in water. They will say the solution is saturated. Then you can say a saturated solution is a solution that contains as much solute as it can dissolve in the presence of undissolved solute particle at a given temperature. So you know when 90 grams of the salt was dissolved in 50 centimeter cube of water, it means you have not all the 90 grams that was dissolved in 50 and was added to 50 centimeter cube of water will dissolve. But we can know the maximum amount that can dissolve from the solubility given here. The solubility of the salt is 8.0 mole per cube. From this solubility, we can get the maximum number of solute that will dissolve in 50 centimeter cube. So what we need to do is to use the formula to get the mass of the solute that will dissolve in 50 centimeter cube of water. So we use solubility is equal to the mass of the solute over the molar mass times 1000 over volume. Now we know the solubility of the salt, 8.0. We want to determine the maximum amount of the solute that will dissolve now. Over what is the molar mass of the salt? Magnesium chloride. That will be 24 plus 2 atoms of chlorine will give us 71. Then times 1000. What's the volume of the water used? 50 centimeters. So that will be 50 centimeters. So this is 8.0 is equal to x over what is 24 plus 71? 95. Times 1000 over 50. You can have 1000x is equal to 8 times 95 times 50. Then from here we can say x is equal to 8 times 95 times 50 divided by 1000. So x is equal to 38. That is 38. It shows that out of 90 grams that was added to water, only 38 grams of the salt dissolved. Then what will be the mass of undissolved salt? Undissolved salt is equal to 90 minus 38. And that will be what? So it means 52 grams of the salt will remain undissolved. Any question on that? So, one more question before I give you the work. So the solubility of copper 2 tetra services is 75 gram in 100 gram of water and 25 gram in 100 gram of water at 30 degrees centigrade. What mass of the salt will crystallize if 50 gram of saturated solution of copper 2 tetra services at 100 degrees centigrade is cooled to 30 degrees centigrade? A solution is made by dissolving a solute in a solvent. From the explanation here from the question, you can say that at high temperature we have more solute dissolved in a solvent. At 100 degrees centigrade, you have 75 grams of the salt dissolved in 100 grams of water. But when the temperature is lower to 30 degrees, how many mass of the solute was dissolved? Only 25 grams dissolved. What we need to do is to find the mass of the solute in a solution. Because look at the question here. What mass of the salt will crystallize in 50 grams of saturated solution? That means we must know what will be the mass of the solution at different temperature. At 100 degrees centigrade, we are having 75 grams of the solute is added to 100 grams of the solvent to give us what? 175 grams of the solution. The mass of solution will be the masses of the solute and the solvent. Are we together? Then at 30 degrees centigrade, we have 25 grams of the solute added to 100 grams of the solvent, and that will give us what? 125 grams of the solution. It means we can say 75 grams of the solute is dissolved in 175 grams of the solution. That is at 100 degrees centigrade. And we can say 25 grams of the solute is dissolved in 125 grams of the solution at 30 degrees centigrade. What we want to look at is that the reference we are making to now is at 50 grams of the solution. That means what we have to do is that we have to change the mass of the solute to mass of the solvent, which is a mass of the solution, which is what? 50 grams. If at 30 degrees, at 100 degrees centigrade, we have 75 grams of the solute in 175 grams of the solution. How many solutes will present in 50 grams of the solution? Because we want to look at the mass that will crystallize if we make use of 50 grams of the solution. So here we can say 75 grams is present in 175. How many grams will present in 50 grams? Because 50 grams is what we need for that calculation. What would that give us? S is equal to 75 times 50 divided by 175. And that gives us 21.43. Now, if 25 grams of the solute is present in 125 grams of the solution, that's at 30 centigrades. How many grams of the solute will present in 50 grams of the solution? Then S is equal to 25 times 50 divided by 125. And this will give us 10 now. At 100 degrees centigrade, the maximum, the number of solutes that are present in 50 grams is 21.43. At 30 degrees centigrade, 50 grams of the solution can only hold what? 10 grams. If you now cool from high temperature to low temperature, what will be the mass of the solute that will remain insoluble? What do we do? Subtract. Because if at 100 degrees centigrade you can only have 21.4, and you know when the temperature is equal to 30, you can only have 10. If you have dissolved 21.43 grams of the salt at 100, if the solution is allowed to cool to 30, you can only have 10 grams there that will dissolve. What will be the mass that will not dissolve? Subtract this from this. So cooling from 100 degrees centigrade to 30 degrees centigrade. You are going to have 21.43 grams solute minus 10 grams crystallizer. That will give us what? 21.43 minus 10 will give us 11.43. That means 11.43 grams of the salt will crystallize out. I told you solubility of a salt increases with increase in temperature. Automatically, the solubility of the salt will decrease by decreasing. So if 21.43 were dissolved in 50 grams at 100 degrees centigrade, by the time you cool it to 30, which can only accommodate 10, it means 11.43 will remain insoluble, and that is what it will crystallize of the solution. Any question on that? Feel free to ask question. There is no question, then try this one for me. Yes. The solubility of a salt of molar mass 101 gram per mole at 20 degrees centigrade is 0.34 mole per 10 cube. If 3.40 grams of the salt is dissolved completely in 250 centimeter cube of water in a beaker. Determine if the solution is saturated, unsaturated, or supersaturated. Is the solution saturated, unsaturated, or supersaturated? Quickly do that, and let's see what your answer will be. Is equal to mass of the solute over the molar mass times 1000 over volume of solvent. The solubility of the salt is given as what? 0.34. Now, what will be the maximum amount of the solute that will dissolve? Over the molar mass of the salt is 101 times 1000 divided by how many volume of water are we using? 250 centimeter cube. We have 250. And from here we can have this is 1000x is equal to 0.34 times 101 times 250. Then you can say x is equal to 0.34 times 101 times 250 divided by 1000. Then x is equal to what? 8.5 grams. It shows that 250 centimeter cube of water can hold as much as what? 8.5. How many mass of the solute will dissolve? 3.4. Is the solution saturated or unsaturated? The solution is what? Unsaturated. That means the solution is, because you have dissolved less than the required number of salt in 250 centimeter cube of solution. So the solution is unsaturated. So till we meet again for another chemistry class, please enjoy yourself.